Firstly, I want to acknowledge the traditional owners of the land upon which the Sydney Central Branch operates from and where I am at the moment, the Gadigal clan of the Eora Nation. We acknowledge their leaders, past, present and emerging, and we also acknowledge their sustainable stewardship of the country over many millennia. I would also like to acknowledge the traditional leaders of other parts of the country or in other lands, wherever you may be joining us from. Tonight, we have the pleasure of welcoming two speakers, Ethan Burns from Sustainability Now, who will speak to us on how residential strata buildings can achieve substantial energy efficiency improvements to common areas. And then we'll have Jack Taylor from Illume, who will talk about their Soul Share system, which is the world's first behind-the-meter solution to shared apartment solar. To our first speaker, Ethan. I first got to know Ethan, an environmental engineer with a background from the power industry, probably about 8-9 years ago, through different Renew events, such as Speed Date, a sustainability expert. Since then, he has grown his business, Sustainability Now, providing over 500 residential strata communities with practical energy and water efficiency solutions. In recent years, he has worked a lot with the City of Sydney Smart Green Apartments program. Would you please welcome Ethan?
Thanks very much, Graham. I'll just get my screen share going. So yes, as Graham mentioned, I'll be talking about energy efficiency in strata in the main, but also briefly touch on solar for residential strata, and Jack will continue on from that. So I thought it best to frame the talk today around a new tool that's available for rating the energy and water efficiency of residential strata complexes, NABERS for apartment buildings. And then we'll go into just the key consumers of energy in a strata situation, and also what changes that you can make to reduce that energy consumption for the common property. Also, what incentive schemes are available for you to help offset the costs of that, and also just provide other assistance from state, local, and federal government. And as I mentioned, just a little bit on PV at the end. I think this is probably one of the most important phrases in the whole thing, is that you can't manage what you can't measure. So you really need to know where you are and what you're using now. Establish a baseline and just measure your ongoing performance against that baseline. Investigate fluctuations from the baseline, and then take advantage of free data, usage data that's offered potentially by your retailer, or look at a third-party monitoring system to keep an eye on that data. Also, understand how you're charged for energy, because the good thing about this is that the more electricity you save, the more carbon you save, but also the more money you save. Here's a couple of examples of how data might be used in this environment. We can see that we've got average daily load profiles over the course of a 24-hour period, and demand there, with a couple of peaks, a peak in the morning and a peak in the afternoon. So understanding what your building's load profile looks like normally, and then being able to recognise deviations from that normal profile is quite helpful. Here's another example. So this is over the course of a month of usage here. You can see that the normal daily profiles are up and down here, but for some reason something's gone wrong here, and you can see for a period of nearly 2 weeks the consumption was elevated, and this was due to a car park ventilation fan remaining on after a fire alarm was triggered and not resetting. So knowing this sort of thing can really help you identify problems early and get them fixed before they create much larger problems. As I mentioned, I think it's good to frame your energy efficiency quest around NABERS. So NABERS is an acronym for National Australian Built Environment Rating System. It's nationally recognised, and it's just a simple 0 to 6 star rating, and it measures your building's actual impact on the environment in terms of carbon emissions and also water consumption, not intent or design. So you might have had, a really good basics rating or a good Green Star pre-construction rating, but this measures actual performance. It's not a new thing. NABERS is more than 20 years old now, and it's been used in the commercial office space for that period, and it's actually been mandatory to disclose in the office space for more than 10 years now. So at the point of sale or lease of office space over 1,000 square metres, you must show a valid NABERS rating. And the thought is that that mandatory disclosure will be coming to residential strata soon. So it's a good opportunity to get in now before it's mandatory and get that star rating as good as possible before it becomes mandatory. So set your baseline now and then try and improve on that baseline. There's just a quick visual there of where NABERS ratings are. So the average should be 3 stars. 1 star would be poor, and then all the way up to market leading 6 stars. I'm only aware of 2 6-star buildings in Australia at the moment, but I'm sure we're going to see that increase over the next year or so. So what are the key contributors to your energy consumption in your residential strata complex? Well, if you've got a centralised air conditioning system or a condenser water system in your building, then more than likely that's going to be far and away the biggest consumer of electricity. The other thing that we see sometimes is, and this should be the case in order to maintain compliance to the standards, is that car park ventilation systems often operate 24 hours a day, 7 days a week. And if they're not controlled by something, so that they only run when required, then that will be a huge energy consumer. Older lighting technologies, so fluorescent tubes in car parks and fire stairs that operate 24 hours a day, halogen downlights and that sort of thing. We don't see too many of those anymore. They've mostly been phased out now. Mercury vapor and metal halide floodlights and high bays and that sort of thing. If you've still got those, then there's some good opportunities there. Pool heating's another one. Gas, the most common form of pool heating is gas. But every once in a while we see a few electric element heaters, which are really inefficient. Also, the age of your building can have an impact, and there are some really new buildings that are really efficient, and they've got all the latest bells and whistles in there to control the use of electricity, and they generally perform pretty well. But interestingly, sometimes some of the much older buildings are actually reasonably good performers because they just don't have any. They just don't have a lot of the technology that the newer buildings have. So it's not necessarily a direct relationship or a direct correlation between the age of the building and the energy consumption. And I guess one of the key things is that whether or not the developer who constructs the building has an ongoing interest in operation and maintenance of the building and paying the electricity bills. If they have no interest, then generally speaking, it's the cheapest available technology that meets the minimum requirements of the building code of Australia. So what are the biggest users? Again, we've got the centralised air conditioning system, HVAC, so bathroom and kitchen ventilation systems, which typically run 24 hours a day, 7 days a week. Car park ventilation, that can be either 24/7 or run off a timer or controlled by carbon monoxide sensors. Your lighting, lifts don't use as much electricity as many people think. They're sitting idle a lot of the time. Pumping water around your building uses a bit too, and then some miscellaneous motors, fans and pumps and that sort of thing. Here's a graphical representation of that. That's just an example of one building in particular I worked on. The split won't be exactly the same for every building. All buildings are generally slightly different. So that's just an example of a breakdown. So what are the low-hanging fruit that you can attack to get the best return on investment? Quite often there's going to be low or no cost opportunities, and that a lot of that centers around, well, the no cost opportunities in particular. Checking your electricity tariff, your network tariff, and also your retail contract. So generally speaking, and I'll apologise, I mentioned this as well, that a lot of what I talk about today will be Sydney centric. That's where I do most of my work, but I think it's generally applicable to to most of the country. So check your electricity. You normally have two components to your electricity tariff. You have a network component, which is just a pass-through cost from whoever owns the poles and wires in your area, and then you have a retail component, and then you have a choice of retailer. So just checking that you're on the right network tariff to start with can make some big savings. It's reasonably common that I find buildings who are not on the correct network tariff, and it's a simple case of filling out a form and they can save thousands of dollars a year in that way. The retail contract, again, it's always good to shop around and also take into consideration the green credentials of your retailer when you're doing that as well. So aside from that, that's just a pure cost saving. You're not going to save any energy in that way most of the time, but looking at what you've got and optimizing what's there, just monitoring and maintaining what you've got will often lead to good savings. And also timers are a good thing as well, and sensors. If a piece of plant doesn't need to be running, if a light doesn't need to be running, if there's no one there, then can you control it with a timer or a sensor? So again, back to other things, and these ones are not necessarily low or no cost. You'll have to spend some money to save some money here, but hopefully with the right business case, you can move forward with that. So T8 fluorescent lights, a lot of these have been upgraded in many buildings to LED with integrated sensors. But there's still plenty of buildings out there that still have 24-hour-a-day fluorescent lights that are burning irrespective of whether anyone's present or not in that area. So there's a very easy business case to replace those with an LED. With quite often they have sensors built into them. Each light fitting has its own sensor that operates independently of the others, and if no one's around, then they either turn off completely or dim down to about 20% of full power. Replacing your 24-hour fluoros in the car park and fire stairs with these sort of things can pay for itself in under 2 years. So it's a really easy project. Again, halogen downlights to LED. I'd probably say that there would be too many buildings left with halogen downlights around the place. I think they've mostly been replaced with LED now. Carbon monoxide or CO sensors on car park ventilation systems. So essentially the Australian standards say that a car park ventilation system should run 24 hours a day, 7 days a week, unless you can monitor the air quality in the car park and then adjust the fans based on that air quality. It's uncommon for us to find car park ventilation systems that are running 24 hours because it's just so expensive. In most cases, they've been put on a timer to coincide with perceived peak movements of vehicles in the building. Again, that's more than likely wasting electricity unnecessarily. So installing carbon monoxide sensors at strategic points throughout the car park and then operating those fans via those sensors will save in some cases they may, run seldomly again after doing that. So that's a nice one. Variable speed drives, VSDs, on pumps and fans. If, as a general rule of thumb, if you have a centrifugal pump or fan and you slow that pump or fan by 20%, you'll make a 50% power saving. So it's not a linear relationship, it's a cubic relationship. So even if you can shave a few hertz off the frequency of the incoming power, you will make some good savings there. So normally you need something to control that VSD, or tell it what to do as far as how fast it needs to go. Power factor correction is another one that doesn't really save much in terms of actual kilowatt hours, but it will save money if your power factor is bad. I won't go into the detail on that here, it's a bit too complicated, but you can Google power factor, have a look on Wikipedia, it explains it quite well. Most buildings, power factor is not really an issue these days. Modern lighting and modern pumps and motors and fans and that sort of thing have sort of fixed a lot of the power factor correction problems. But overall, if you haven't really undertaken any energy efficiency upgrades, you could be looking at up to 40% savings, 40% on average, and up to 90 in some cases if your building is really inefficient to start with. Electricity tariffs. Again, this is not really an efficiency measure in terms of saving electricity, but it's a cost saving, and you can actually, if you make those cost savings, then you can turn those savings into other projects. So just understand how your electricity tariff works and how you build, and just make sure that you're optimizing your use based on that tariff. So time of use tariffs, TOU, peak, shoulder and off-peak billing periods. If you have an item of plant that doesn't need to run during peak periods, then can you put a timer on it and make it run during off-peak periods? Can you, is your building subject to demand charges? That's something that's worth looking at. In Sydney, buildings that use over 160 megawatt hours a year are subject, or over 100 megawatt hours are subject to a demand charge that is measured and billed on a 12-month rolling maximum, which is particularly punitive. So once you hit a new high on your demand charge, then it resets itself and you're billed for the next 12 months on that, and it won't reset and lower again until you've gone past that 12 months. So keeping an eye on those things is really important. One building in particular, I noticed a contractor was doing routine testing on car park ventilation fans and doing it right in the middle of peak billing periods. And the result was that the building's billed KVA demand charge doubled just because of testing. And it was costing them something like $14,000 a year extra, or more than it needed to, just because the contractor didn't understand how the tariff worked. So how do we save electricity? There's two key ways. One, we can just reduce the hours of operation or the time of operation. So turn things off when we're not using them, and we can use timers and sensors to do that in their simplest form, or reduce the power consumption of the device. So it's your consumption charge, kilowatt hours, is a factor of watts and time. So if we can turn it off, or we can reduce its wattage. So again, as I mentioned before, slowing pumps and fans down with variable speed drives, replacing older technology with more efficient, or retrofitting what you've got, and maintaining. So that's an important one, is just making sure that your maintenance schedule is up to date for all of these items of plant. So saving natural gas again as well. Many of your centralized gas hot water systems will be gas fired. It's quite often I see uninsulated hot water pipe work in ring mains around the place. So essentially your gas hot water system's acting like a cooling tower. You're losing lots and lots of heat through that pipe work. When your contractors do work on your plumbers do work on your hot water system, do they replace the lagging and the insulation around that pipe work? The other big user of gas in residential strata buildings is heating swimming pools. It's very, very rare that I ever see a residential strata building that has a pool cover on their pool. It's such a low cost and simple way to reduce heat loss through that pool, but they're seldom used. Again, reducing thermostat temperatures, the bigger the differential between ambient temperature and the thing you're trying to heat, the faster the rate of cooling. And also, with your hot water system, can you preheat it with something, perhaps with solar thermal or a heat exchanger, or using electric heat pumps? I think there was a seminar recently on electric heat pumps that was quite informative that you can look up. The other thing that you can look at is fuel switching on gas appliances. So traditionally, gas has been a lot cheaper to purchase than electricity on a unit heat basis. But I think the dynamics on that are changing, and they're probably tipped to increase further now that the east coast of Australia is exposed to the export market. So exporting of our gas offshore may be more lucrative than using it onshore. The other issue that comes along with our gas is that a high proportion of it is coal seam gas, and there's issues associated with water tables and farmland around that. And it's just more efficient, I suppose. Electric heat pumps can be greater than 4 times more efficient than an equivalent gas heater. So you might have a coefficient of performance of 4 or 5 or up to 5 maybe for an electric heat pump versus maybe 0.8 for a gas heater that just loses. You'll never get more than the same number of watt hours or kilowatts or megajoules in and out. Pool heating, switching your gas or electric element heater to an electric heat pump can pay for itself in as low as 12 months, but up to 3 years as well. Domestic hot water, converting your large gas domestic hot water system to a heat pump is a little bit harder, but we won't go into the detail of that. So while you're doing all of this, you need to maintain your standards. So particularly, here's 3 that come up all the time. AS 1680 for general lighting, AS 2293 for emergency lighting, and AS 1668.2 for mechanical ventilation. So whenever you're doing a project, you just want to make sure that you're maintaining that standard. Government incentives, there's lots of them out there. And again, I apologise if this is Sydney centric, but just check, start with your local council's sustainability department and find out, it's probably a good place to start with. See if they've got anything going. Your state government may have something as well. In New South Wales, we have a really great program called the Energy Savings Scheme. Victoria has a very similar one, the Victorian Energy Upgrades VEU program. And we also have a really good renewable energy target for help with our solar PV systems. So yes, moving on to solar PV. If you're looking at installing solar, you ideally want an unshaded north-facing aspect. East or west's okay, not as ideal as north. We generally don't install solar on a southern aspect. You won't get a good return on that. You can get small trading certificates and also LGCs for bigger systems over 100 kilowatts in size. And that's linked to the renewable energy target. So there's some good rebates there. Micro inverters are a really handy little thing for shaded areas and splitting up PV systems. Instead of having a large string inverter, one single string inverter per array, you have each individual panel has its own micro inverter. So it allows your solar system to be a little bit more versatile in how you lay it out. It gets a little bit difficult when you've got 6 or more floors on your residential strata complex, but it's not impossible. You might just have to spend a little bit more on crane hire. The price has been continuously decreasing over time, despite the fact that the incentive schemes, the STCs and LGCs are sort of winding back. Even so, the cost of technology is dropping all the time, and we're seeing a continuous decrease in price. So I'm seeing regularly payback periods from between 2 and it's not often I see 10 years anymore, unless it's a really tricky installation. But I would say 5 is very common. Sort of 3 to 5 years is very common now for a payback period on a solar system, which is excellent because it's a 25-year life of system, so it's going to pay for itself many times over. Batteries, a lot of talk about that at the moment, and they can be viable with the right time of use tariff. If you use your battery to offset your peak electricity, you can get quite a good return on investment, faster than the warranty period. So there's 3 broad options to connect your solar PV system on your residential strata building. One is just on the common property, direct to the existing utility meter. Then you can also, if your building is configured the right way, you can also connect a PV system directly to the tenancy meters. It's really only suitable for smaller buildings. Otherwise, the wiring starts getting a little bit complicated, wiring back to more than, say, 10 apartments, but it's not impossible. There's this other thing as well, Australian Standard 4777, which can be problematic, that says that if you have more than 30 kilowatts of solar installed on your building, running through the same connection point, then essentially you need a protection relay, a master protection relay, and then also a sub relay on each individual point of connection. So for example, if you had a building with 30 apartments and 1 common property connection, and the total array size was over 30 kilowatts, you would need a protection relay on the main entry to the connection point to the building, and then a sub relay on each of the 31 other connection points. And that starts getting very, very expensive. And that's where things like a loom come in, and Jack will talk more about that in a minute. It's a behind the meter system. So in that scenario I just mentioned, if you were using a loom to distribute your electricity to the tenancies behind the meter, you would really only need that 1 protection relay. So it can save a lot of money. Green power is another thing you should consider. If you can't put solar on your building, there's many apartment buildings where solar is just not practical. If you can just buy green power, accredited green power. It's probably the simplest and easiest way for you to take advantage of renewable electricity and no carbon electricity. It's the Green Power program is the only government accredited program, and it's available through most retailers. But you can also buy it retrospectively, and it sends a nice price signal to the government that we want renewable electricity. And it will also have a direct impact on your NABERS rating. Okay, some challenges to consider in Strata, and this can be very complicated, but you've just got to kind of play it by ear, I guess. That you've got several decision makers rather than one in a business, and the decision makers may not be technical people. They're volunteers on a committee. So it's explaining it in terms of financial return and that sort of thing may not be the most appropriate way to go. There's also investor owners out there, I guess, who have an aversion to opportunities that have more than a 2-year payback period. And also there's other lack of financial incentive compared to businesses. But the other thing as well is that in New South Wales in particular, you need a special resolution at a general meeting, to alter common property, and that can be a little bit challenging in itself. So I see I'm going over time here. I've got some case studies, but I think maybe we might have to skip those for now. Would you say that's fair, Graham?
No, I'm happy for you to continue. I think the case studies are really interesting.
Okay, no worries. All right, so here's a case study here. This is a building in Chatswood in Sydney, 255 apartments built in 2001. The first project they did was an LED lighting upgrade for the common area. So they went around and replaced all their 24-hour fluoros in their car park and fire stairs with an LED sensor light. In the fire stair areas, the savings on the LED sensor lights, when it's very rare that anyone goes into a fire stair. So these things just dim down to about 20% of their rated power when there's no one around. The savings there were in excess of 90%. A little bit less in the car park where there's a bit more movement around, but substantial savings in a very, very fast payback period. They also installed carbon monoxide sensors in their car park to control their ventilation fans in there. So those fans only ever operate when the carbon monoxide levels get above 9 parts per million, which is pretty much never. And when they do operate, they operate at a low VSD speed, and then the VSD can ramp up to a higher speed if necessary to clear that air. They also installed a variable speed drive on their condenser water pump, and that made a really good saving as well. The pump was found to be oversized for its application and was providing pressures far higher than were necessary throughout the pipe work. So that was able to be wound down significantly, and also wound down again in winter when it wasn't used as much. This building also installed a power factor correction unit as well that saved them quite a lot of money. After we did all that, we put in a form to Ausgrid, who are the network provider there, and got their peak capacity reset. If you remember, I talked briefly about that before, that they were charged on a 12-month rolling maximum. So if you undertake energy efficiency projects like this in the Ausgrid network area, and you can show evidence that you've lowered your demand, you just fill out a form and send it in. And rather than having to wait 12 months for those savings to be realised on your KVA demand charge, they'll just reset it almost straight away, so you can start making those savings instantly. So they're saving about $87,500 a year annually, and their carbon emissions reduced by 609 tonnes per annum. So that's a pretty good saving. Here's an example of their load profiles before and after. You can see in the red, this was their car park ventilation system operating via a timer. So it was running all the time during from about 7 o'clock in the morning until about 10:30, and then again from about 4 p.m. until about 8 p.m. So this was all completely unnecessary. We were able to just essentially cut that right out with the carbon monoxide sensors. You can see here that the base load overnight between the red and the blue has dropped by more than 50 kVA, and again that was due to the lighting upgrade, but also the condenser water pump. So huge savings at that building there. There's an example. There's a picture of the condenser water pump, and you can see the variable speed drive there that controls that pump now. Zinc apartments at 30 Garden Street, Alexandria. Actually, this one's slightly out of date. They've 67% savings. They've actually just installed recently a second PV system on their roof. I think they've got nearly 30 kilowatts up there now. So their energy savings are huge. Again, only 45 apartments here, built in 2005. They did an LED lighting upgrade, pretty much exactly the same as what I just mentioned. In addition to that, they also replaced all their halogen downlights throughout their corridors with LED equivalents. So made 85% savings there on those ones as well. Installed an 8.5 kilowatt PV system, and again they've just installed another one again, and they're just under 30 now, I think. We also, again, this was one of those buildings that was on the once we undertook all of these works, it allowed them to drop back a network tariff. So we were able to, again, to put the same form in and ask them to reset their network tariff, and they made some great savings there. So a smaller building, the savings are proportionally smaller, so about $9,500 a year. And this building will be a 6-star building next year when we re-rate them for NABERS after these projects. You can see there the difference in their load profile, and this is where you can see the solar makes a difference. You can see this curve here. So their consumption, this was the base load consumption saving they made. Their morning peak comes up here, and then the sun starts coming out, and then the solar puts a nice big hole in their daytime demand until we get back into the afternoon again. So yeah, that was a really good project. You can see here, it's a bit hard to see, I suppose, but where we started back in October 2013, I think they were looking at about 166 kilowatt hours a day, or $37 a day. Did their LED lighting upgrade, that dropped down to 105 kilowatt hours a day and $23 a day in cost. In December 2016, we adjusted their tariff bracket, and they went from $23 a day down to $17. And when they put their solar system on, they went again from 101 kilowatt hours a day down to 54. And also their cost went from $17 down to $11 a day. So they've done really well. There's a picture of their PV system up on their roof. That one's just connected to the common property, so there's no connection to tenancies there. But that building is relatively low rise. I think it's only about 5 stories, and they've got quite a large roof area. So they may consider doing installing more PV up there and looking at something like a loom to connect to the tenancies as well. Number 3, Capella Apartments in Kensington, New South Wales, 164 apartments built in 2006. Again, the same LED, you'll see that these things just keep coming up again and again and again, the same LED lighting upgrade. They put 27.5 kilowatts of PV connected to their common property meter. They did that in 2 stages. They did 17.5 to start with, and then put another 10 on. Roof space was a limiting factor for these guys, so they basically just maxed out their available roof space with PV, put as much as they could fit up there. They could have actually taken a bit more in order to reduce their daytime demand, but that's something that we find very regularly. It's unusual that a building of a size like that, 164 apartments, usually there's just not enough roof area up there to completely take out their daytime demand and export to the grid. So it's, in this case, it was just a case of just using every bit of available space for solar. Again, we reset their capacity charge, and they're saving $37,200 a year in electricity costs, and lowered their carbon emissions by 255 tonnes per annum. Here's a graph of their load profile. You can see the red graph was before we started work, and then after. So they've reduced their base load by 20 kVA or kilowatts. And then again, this same sort of shaped load profile as zinc. This is the solar taking a nice big chunk out of the middle of their load profile during the day. And as I said, they could probably have put another 30 kilowatts up there or something to sort of take this bit out here, but they just didn't have enough roof space. So that's the good thing about solar, though. Every little bit helps. So some buildings, sort of put off by the fact that they can't fit a huge system up there, but it's still worth doing. As it'll still take a nice little chunk out of the daytime load profile. There's some photos of the PV installation at Capella, so you can see. Yeah. That's that. So I think that's basically the end of my my presentation.
Thanks, Ethan. There's a lot of options there, and seeing the case studies, I mean, lots of financial savings, but also what's important is all those emission reductions that are occurring as well. We have a few questions have come in. I think at this point we'd probably just do 4 questions and then we'll move on to Jack.
Sure.
So question from Jenny. A lot of apartments, community buildings are embedded networks. There is no redress to this except through body corporate, which may not understand or want to change. What do you do then?
I would guess that maybe Jenny's from Victoria. There seems to be a lot of embedded networks in Victoria. We don't have as many in New South Wales, and they can be an issue. And if the developer has constructed the building with an embedded network in there, then there's a cost to, I guess, try and remove that embedded network and take it back to a normal situation where the supply authority owns the electricity meters or the retailer owns the electricity meters, and often there's a cost associated with that the lot owner ends up having to bear if they it's sort of written into the fine print of their contract. It's a tough one, and without knowing the specific details, it's hard to advise really on what the best course of action is. But I would always suggest that perhaps it's worth talking to the state energy ombudsman to find out what your personal rights are in that regard, and if there is any option for making a change.
Great. The next question's from Kerry. Ethan, is it true that LEDs, while individually efficient, are being used so excessively, whole rows of lights and many multiples where previously only 1 or 2 were used, that they are now becoming a much higher energy user than assumed or expected?
I wouldn't say that is a common situation. I mean, when you're doing a lighting upgrade, hopefully the lighting provider is using a like-for-like product. So the LED replacement should have a similar light output to what was there previously. So you should get a similar result. But the way to check that is you can use design software where it'll load and upload a data template for that particular light and show how its distribution and it should shine in that area. And you can do a lighting design to avoid that situation. Similarly, you can also take light readings before and after when you do the installation to see if you meet the Australian standards to start with, and then also if your upgrade is also meets the Australian standards, but again doesn't exceed the Australian standards either. There's no need to go above and beyond what's required of AS 1680. So yeah, I would say that is a pretty rare situation in my experience, unless your existing layout was terribly inefficient or terribly well below the standards, and what was installed, because it's usually a requirement, especially in New South Wales or also in Victoria for the New South Wales energy saving scheme. If you're going to take financial advantage of that scheme, then the installation that is put in there must meet the Australian standards. So if you had a really sparse lighting layout before the upgrade and it wasn't anywhere near compliant to the standards, and they had to install a lot of extra lights to bring it up to the standards, then maybe it might be a possibility that it uses more electricity, but I'd say it'd be fairly rare.
Okay, the next question is from Anjit. By demand charges, are you looking for the unit's individual demand charge or the demand charge that contributes to the building peak? I assume it's the building.
That's right. So everything I've talked about today, apart from the little bit of solar at the end, connecting solar to tenancies, it's all about common property. So we're generally only looking at common property here. So I can't speak to the different electricity tariffs outside of New South Wales too much for individual dwellings, but I have heard that there are some demand charges perhaps in Victoria somewhere for residential customers, but it's probably pretty rare that any any residential tenancy would be subject to a demand charge. It's usually only big consumers. So, for example, in Sydney, you have to use more than 100 megawatt hours of electricity a year before you're subject to a demand charge.
The next one is from Jessica. Have you got any tips for hot water systems for small multi-unit dwellings, say under 10 units, where centralised heat pump hot water systems aren't financially viable?
Yeah.
The heat pumps are often too large for these type of units, townhouses. And I guess traditionally those type of units probably had a 50-litre electric storage system.
Yeah, that's it. And the other issue, I guess, with heat pumps is you need to be able to vent them somewhere. You don't want that cool air collecting on any surfaces and then condensing and causing damp and mold issues and that sort of thing. So that's a problem. Yeah, unfortunately, I mean, someone might correct me here, but I don't know that there's really that much available for those really small electric storage units. Unfortunately, with those sort of things, it's 1 kilowatt in, and if you're lucky, you get 1 kilowatt of heat out. I have heard of some people using instantaneous units as well. So you're not storing anything, so you're not really losing any heat there. That could be an option, but I've heard the current draw on those things is pretty intense. So you've got to make sure that your existing wiring is up to the task on those. But yeah, it is unfortunate.
It could, if the building's suitable, it could be a case for a PV system, and then you fit timers to the small hot water systems so that they come on during the day.
Yeah, that's it. And also, yeah, there's if you do have an individual tenancy connection to a PV system, there's those I can't remember the name, but there's heaps. They've been talked about at length in Renew magazine, where they just trickle any available excess electricity that would otherwise be exported to the grid. They trickle it into your hot water system, so it's like a solar diverter. Mm-hmm. So that's a good option, definitely, if you do have access to solar.
Okay, we'll leave the questions there. There's still more, but we'll come back to them. But I think it's time to invite our other speaker, Jack Taylor. Jack's from Illume. Jack's passion for engineering and the environment has led him to become the head of technical sales at Illume Energy. He works on partnerships and business development to deploy Illume's Soul Share technology. Can you please welcome Jack?
Oh, hi everyone. Thanks for that, Graham, and thanks, Ethan. As Ethan mentioned, I'm going to be talking a little bit about our Soul Share technology, which will enable you to install solar panels on the roof and get solar energy for your individual apartments within the building. As an introduction, I think Graham mentioned I head up the business development for Illume Energy, and I'll talk to you about getting solar on your apartment buildings. So we're all very aware of the benefits of solar energy for standalone homes. It's a tried and tested method to reduce electricity bills, reduce your carbon footprint, essentially save money and save the planet. But apartment buildings have historically been left out. And that's because some of the technical challenges of getting solar onto an apartment building and distributing that to the apartments within the building. So what are the solutions on the market at the moment? So there's common line power. Ethan mentioned this, where you have a small system that's hooked up to your common line power load. So that would be powering things like the lift and the hallway lights, the car park exhaust fans, for example, which is obviously great. It's great to reduce that bill. It's great to reduce that carbon impact of the communal lights. But as you can see from that example photo, quite often that leaves you with this huge amount of potential roof space for solar, and only a tiny amount of it actually being utilized, because essentially you're only covering the small load of the common light and power and not getting that benefit to the apartments. I think a couple of people have talked about embedded networks. So embedded networks, if you're not familiar, is when a company will come in and install an electrical retail network within your apartment building and sell you the energy. So sometimes they can include a solar system into this, but it can be a little bit counterintuitive to their or counter to their business model of being able to make money from selling a large amount of energy to the building as a whole. So it is an option, but it's quite a complicated option. It's quite an expensive option, and yeah, it's quite challenging because everybody has to be on the same energy retailer as well, which is often a slightly uncomfortable thing to be able to push to everybody in the building. So there's now a third option. It's the option that I'm going to be focusing on today, and it's the Soul Share. So Illum Energy, based in Victoria, has developed the world's first behind-the-meter solar sharing solution. And it's designed and manufactured right here in Australia, in Victoria. So something that we're really proud of, and something that we're taking to market, not just in Australia, but across the world. So what is the Soul Share, and what is a behind-the-meter solar sharing solution? So essentially what it does is it takes the energy produced from a single system, so a single set of panels and inverter, and it goes into the Soul Share and then distributes this energy behind the meter to all the meters in the apartment building. So that means that all the apartments and the common light and power, so sort of whatever loads there may be, can get attached to the single system, and everybody can enjoy the benefits of the solar energy, not just the common light and power. It can be every apartment in the building. So what this means, the behind the meter element means that it's actually attached to your or fed into your apartment between the meter and your apartment. So you stay on the NEM. So that means that everybody in the apartment will be able to choose the energy retailer. There's full flexibility around there. As Ethan mentioned, you can get your power from green power, so you can get green energy supplied to you from the grid. And then when the solar is generating, you'll get the free solar energy that's produced on the roof. So as I mentioned, this is a world first. There's nothing else like it on the market, and that's probably why typically if you've done any sort of exploration into getting solar on your apartment, you may have become a bit unstuck because you may not have been able to find our product. So we're really excited about this. We're really excited about getting it to the market. And we're well established in Victoria, South Australia, and we've recently entered the New South Wales market. So this is a great opportunity for us to get some solar systems installed up there. We've already got a few in Neutral Bay and Ryde, but of course, the more the merrier. We can get more people saving money and saving carbon emissions. So the Solar Share is not just a sort of idle system. What it does is it monitors everybody's demand in the apartment building, and it distributes the solar to wherever it's needed at any specific time. So that works on both a sort of a micro and a macro scale. So micro scale being when you flick on your kettle or your AC or whatever it may be, you'll get the solar energy supplied to your apartment to make sure that you save the money at that point. And then when your neighbors do similar actions like that at slightly different times to you, they'll get the solar. So you have that sort of sharing element, and you have an optimized system. That also works on a sort of a macro scale as well. So if you go on holiday maybe for a week, the Soul Share will automatically notice that you're not using much demand, maybe a little bit for your fridge, for example, but it will limit the amount of solar that's sent to your apartment, and it will increase the delivery to the solar to the other apartments in the building. And then when you come back from holiday, it'll notice that you're back. It'll notice that you haven't been receiving much solar over the last week, and so it will start giving you lots of solar and let you catch up with your neighbors. And that's another really important part of the technology. So we understand that if you've all bought into the system the same amount, you all want the same amount of benefit from the system. So over the course of a month, we log how much solar has been sent to each of the apartments, And if somebody's received a little bit more or a little bit less, then what we do is the soul share automatically ramps up and ramps down that solar delivery, so that at the end of the month, everybody's received the same amount of solar energy. So it's a very active system, and it gives you all the same amount of energy, but what it does is it gets you that energy when you're going to save the most amount of money. So compared to your compared to if you were to install or you have sort of lots of individual systems, you get about anywhere between a sort of a 20 to 40% increase in on-site consumption. And that means you get about a 20 to 40% increase on savings on your electricity bill as well. Well, it's also, the final point is that it's a very flexible system. So you can do it on an opt-in basis. So if there are some people in the apartments that aren't that keen on it, they don't have to be forced into joining the system. So we have lots of connections that come out of the Illume system, and they can be connected to however many apartments that want to be joined in on the system. Obviously, it'd be great if everybody joins in, but if there are a few people that don't want to get involved or maybe can't afford it, it's not a problem. We'll just connect the apartments that can. So what does this mean? It means that instead of your apartment building looking like this, it can look something more like this. So this is an install that we've done in Victoria. So it's a 60 kilowatt system that's distributing to 44 apartments within the building. So that's 1.36 kilowatts of inverter capacity per apartment, which may not sound like much. For those of you who have explored or know a bit about sort of standalone home solar systems, you may think, well, a typical standalone home needs 3, 4, 5 kilowatts of solar to really get a good benefit. But that's the advantage of the soul share system. It's because you've got that bigger system and everybody has access to a sort of a larger pool of solar, and it works off those sort of micro macro changes as I talked about earlier. That relatively small amount of solar, that sort of 1 to 2 kilowatts of solar per apartment, actually does a huge amount for reducing your energy bills. So that sort of 1 to 2 kilowatts of solar, we'll typically see anywhere between sort of 40–45% reduction in your energy bills. Here on this particular case study, they've had a 21% increase in solar consumption due to the soul share. And the actual cost of this system turned out to be just $2,000 per apartment. So again, because it's a communal system and you get economies of scale, it's actually a lot more affordable than if you're installing a say 5 kilowatt system on your own standalone home. Now the price varies, so depending on the complexity of your of the install, if there are any challenges, Ethan mentioned needing cranes, for example, earlier. If there's things like this, the price can fluctuate. It can be less than $2,000, it can be more, say sort of $3,000 per apartment. But it's still a very reasonable amount of money to pay up for the system if you are buying it as an outright capex. So with this case study, what's it done? So it's saved 47% of the grid's consumed energy. So 47% of their energy bills have been reduced, and that's a saving per household of over $400, which is a payback period of just 5 years. So this is on a system that's going to last 20–25 years. But not just this sort of payback, you also get the payback that comes with the increased property price as well of having a solar enabled apartment, which is of course quite a rare thing. So it's seen as quite a sought after thing in the marketplace. This is quite an energy efficient apartment building, so that's why we've got a good grid consumption reduction. And but what on your apartment building, maybe slightly less grid consumption, maybe slightly more, and could be actually a higher savings per year as well, because you'll actually be able to save more money if you have a slightly sort of less energy efficient apartment building. And as in terms of an actual sort of carbon reduction saving, this site alone is saving over 100 tons of CO2 per year. So it's a really significant amount of contribution to the reduction of carbon emissions as well. So if you're interested in getting a soul share system, what are the options and what do you have to do? So Bloom Energy design and manufacture the soul shares, as I mentioned earlier, and we actually sell the soul share to our network of partners around Australia. So those partners can install a system in a variety of ways, and the two main ones is a CapEx. So that's quite a sort of a typical system where a solar installer, one of the solar installers, will price up the entire system, so panels and inverter, the soul share, labor, etc. And they can provide you with a proposal. We've got a number of installers, so you can get multiple proposals as well. And then you can take that to your body corporate, and you can vote on whether you'd like the system installed or not. And once you get the vote, there's various voting techniques, voting criteria. But for solar in New South Wales, it can be as little as getting over 50% of the owners' corporation to actually vote yes to the system, and you get the opportunity to actually install the system. And this can be bought as a sort of a raising the levy, or also being able to do it on finance as well. So there are various funding options for that as well. The other option, this is sort of the other side of the fence to be able to pay for it outright, is the no upfront cost model. So we've also partnered with energy retailers as well. And what they're able to do is they're able to come to site and install the full soul share system onto the roof. And then they can offer an energy plus solar retail package that's going to be less than what you're paying for your grid energy package. So you're saving money on your energy bills because they're able to offer you that lower price, because they're able to supply you with solar energy from the system that's installed on the roof. So you save your money and you get that reduced carbon footprint, but don't actually have to pay for the system yourself. So they monitor the system, and they service the system and everything themselves. So you don't actually have to worry about it. And that's on an opt-in basis as well. So if there are some people in the apartment building that don't want to join the sort of the solar retail package, they don't have to. And there are no sort of long-term commitments. So it's not like an embedded network where if you say yes to it, you're locked into it for 5, 10, 20 years. So it's a very flexible system, and it also provides the opportunity to make sure that with this solar system on the roof, you can be guaranteed to have a really good energy rate that's going to be significantly cheaper than what you can get from a competitive grid supplied energy rate. So there are the two options: CapEx, where you pay for the system up front and you enjoy free solar energy, and the no upfront cost, where you don't have to pay anything up front and you get reduced electricity bills because of the discounted rate that you can get the energy for. And of course, both of these systems, you're enjoying the fact that you're going to be able to use green renewable energy that's generated from the apartment building roof. And to have a little bit of perspective on what that is, so a typical system, each apartment will be saving a ton of CO2 entering the atmosphere each year. So quite simply, if you're a 20 apartment building and we install a system on the roof, you'll be saving 20 tons of CO2 from entering the atmosphere. So it's really quite a substantial amount. And 20 tons of CO2, to put that in perspective, is the equivalent of driving your average sort of family car 200,000 kilometers. So 200,000 kilometers of equivalent driving that will be saved from having a solar share system on the roof of a 20 apartment building. So it's a really, really great way of being able to do your bit for climate change. So if that's of interest to you, if you want to know more, if you want to find out more, or interested in looking into the system, please contact me, go into the website, and I can give you a bit more information and introduce you to some of our installation partners who can provide you with more information, some quotes, and details of those two delivery models. Thank you very much.
Thanks, Jack. We certainly have a few questions that have come in. Some are fairly straightforward, such as the one from Robin. Can we get sole share in the ACT?
You can, yes. So at the moment, we have partners in ACT and Victoria, New South Wales, Tasmania, South Australia, and we're just about to enter the Queensland market. That's not to say that we can't do installs in Western Australia and Northern Territory as well. We just haven't entered that market quite yet. So yes, you can get it in the ACT.
Great. Question from Megan. Wouldn't you need a super large roof space to service all apartments and common areas? Or does it just generate a portion of overall energy use? I guess it just depends on the building configuration.
Yeah, exactly. So one of the first things that we'll look at and we'll assess is how much roof space you've got available to solar and how many apartments you've got within the building. And if there's enough, if we hit that sort of that golden ratio, sort of 1 to 2 kilowatts per apartment, then great, we can install solar on all the apartments. But if there's not, then we're about to do an install in Victoria. There's 62 apartments, but there's only enough solar on the roof to do the common line power in 15 apartments. So actually what we've done is they went back to the body corporate and said, look, we can put solar on the roof, but only enough to give 15 apartments a reasonable reduction in their energy consumption. So who would like it? And the first 15 owners who put their hands up have won the system, and so those 15 owners are actually paying for the system and buying the system and receiving the solar energy, and the other sort of 47 apartments aren't. So it's a simple case of us having a bit of a look at the ratio of what the building's like and how much we can actually provide.
Right. Mike is asking, could you explain the basis of how the solar generation is shared in more detail? If I'm not at home using energy during the day, will I still benefit from the solar?
Yeah, absolutely. So, we have a look at what your demand is. So we constantly monitor the demand, and every 200 milliseconds, so sort of 5 times every second, we change the distribution of the solar to maximize the on-site consumption. So, and then we make sure that over the course of the month, everybody's received the same amount of solar. So what that means is if you are away, if you're out of the house during the day, the solar share will notice that you've probably just got a small load, maybe your fridge load, a few items on standby, and it will just deliver you a little amount of solar during the day. And then when you've come home, it will realize that you've come home, and in the morning when you wake up, it will realize that you're awake in the morning, and when you flick on those appliances, it will start sending you the solar. But because it will realize that you're not home during the day, and it will still try and get you the same amount of solar energy as the other apartments. It will sort of have a bit of a prioritization over your apartment when you're using those appliances when you're actually in the house. And so over the weekend, you may receive a little bit more than your neighbors, and towards the end of the month, you'll start receiving an even sort of higher priority over them. And if you receive more solar, this goes with everybody in the apartment. If you receive more solar than you actually use, then you get the feed-in tariff as well. So you can actually start making money with sending energy back to the grid. So yeah, it's all about when you use the power, and the solar share does its very best to make sure that everybody gets their fair share of savings from the solar.
Okay, great. This is from Richard, have you already installed SolShare systems with battery storage? We have, yes. And we're about to do another one in the next couple of weeks down in South Australia. We don't really mind where the power comes from. It's essentially sort of an intelligent switching device. So if the energy is being sent to us via the solar panels, then we'll just distribute it then. But if it's being sent to us via a battery, we distribute it just as though it was coming from the solar. But what we're able to do is we're able to sort of
look at the site as a whole, we're able to see when's most beneficial to charge or discharge the battery as a sort of an apartment group, to again save the most amount of energy. So the battery will automatically know when to charge and discharge, and send it to your to the apartment, so that everybody saves the most amount.
Okay, good. This is a question that might put you on the spot. I think it comes from Robin. What is the cost for, say, 100 apartment development?
So this will probably go back to the previous question about having enough roof space for apartments. So typically in a 100 apartment building would probably be quite a tall apartment building. So it may not be possible to install for all 100 apartments. But if we say, let's go for, I don't know, well, let's use the example that I gave. It's the 44 apartment buildings, 44 apartment building. It was about a sort of $100,000 system. So we're talking about sort of $2,000 per apartment. So each apartment will be different. Each apartment will have its own sort of little quirks and stuff that we'll have to have a look at. And like I said, the real thing that we have to look at is your 100 apartment building 20 floors high with 5 apartments on each level, or is it 5 floors high with 20 apartments on each level? Because if it's the latter, then we'll be able to install enough solar on the roof to cover all of the apartments. But if it's the prior, then we'd probably have to look on the roof and say, well, maybe it's actually more advantageous to install for just the common line power, or the common line power and 10 apartments within the building. So we have to work on a bit of a case-by-case basis.
Okay, I think I might ask Ethan to join us again because there's still a few questions for him. But while he's coming on, one more question for you, Jack.
Far away.
What is the ratio of buildings owned by one owner versus strata with many owners that have taken up sole share so far?
If I can interpret that question in the right way, about 25% of all households in all standalone homes in Australia have got solar, and a fraction of a percentage of apartment buildings have got solar for the challenging reasons that we talked about earlier. But as it stands, we've got 42 installs happening in the next 6 weeks, and we're averaging 30 to 40 installs a month already booked in for the rest of the year. So we're rapidly trying to close that gap.
Okay, great. Question for Ethan from Jessica. If you had the option to design a multi-unit development site from scratch and make all of the right energy efficiency choices from the start, what would your top 5 things to focus on be? Mine, one of them would be the thermal comfort of the individual apartments.
Yeah, I think that's a really good one, because that determines what sort of air conditioning systems they're going to need, if any at all. And if they're designed really well, maybe they don't need any sort of air conditioning systems. So therefore, you don't need a centralized system, which is, as we said before, the biggest consumer of common property electricity, if you have one on your building. But also it might negate the need to have a split system or something like that for the apartment as well. So yeah, that's definitely a big one. And I guess in my focus, I don't get heavily involved in the thermal comfort of individual apartments as such, because I'm looking at the common property plant. And certainly, yes, if you do have bad comfort levels, then that's going to have a massive impact on the operation of a centralized air conditioning system. So that is, yeah, it's definitely a big consideration. But in terms of just general common property items, then if you were to make sure that your lighting is best practice right from the beginning. So there's still no requirement for developers to, not use 24-hour fluorescent lights. As long as they meet Section J of the BCA, then they can, they're meeting the minimum requirements, and they can get away with fluorescence doing that. But going that step above and installing an LED system that has sensors built into it to control those lights would make a lot of sense. Similarly, carbon monoxide control for the car park ventilation system. Again, that's a big one. Someone posted another question on here as well that I saw. I was scrolling through before. Should there be some advocacy around changing the Australian standards? Well, no, not really. I mean, they're pretty good as they are for that particular thing, for the mechanical ventilation of the car parks. It's certainly a risk-based thing. So it's saying just monitor the air quality. You don't need to run them unless you get adverse air quality. So that's a really easy one. So that's so lighting, ventilation. The other thing as well is there's newer buildings out there that have, so you have to have 24-hour mechanical ventilation for toilets and bathrooms and that sort of thing, and sometimes kitchens as well. In most older buildings, those fans just run 24 hours a day, 7 days a week, which is what they need to do to meet the standards. But there's some systems available now that are linked to the light switch in the bathroom. So if there's a ventilation stack that supplies 5 apartments, say, that will only, the ventilation fan will only kick in if at least one of those apartments has its bathroom light on. Otherwise, it will just remain off the whole time. So that's quite a good system as well. Integrated solar into the building, straight away, right from the beginning, makes a lot of sense as well. Looking at using your roof space for PV rather than stacking split system air conditioners and that sort of thing up on the roof that take up a lot of space, like the outdoor units and that sort of thing, and basically prevent you from installing solar. Using that roof space to better utility than just stacking HVAC equipment and that sort of thing is another one as well. But moving away from centralized air conditioning systems, if possible, by any means necessary, is a good one as well. So that I guess there's a little bit of an equity there in that if you do have a centralized system, then everybody is subsidizing the cost of running that system and maintaining that system, even if they don't use their air conditioning. Whereas if each individual apartment has its own standalone system metered through the tenancy meter, then I guess that's a little bit more equitable.
Okay, this is a question that either of you could answer from Nigel. It says, how do I convince other unit owners who are paranoid about historic flat roof drainage problems that installing panels will not cause leaks?
Sorry, I just I missed the first. Is that to me or Jack?
Well, either of you could answer it. I guess it's just about general solar installations.
Sure. I mean, I guess when you're a lot of solar systems, depending on the profile of your roof, and if you've got an existing ColourBond type roof or other metal roof like trim deck or that sort of thing, you're often able to utilize the existing roof screws that are there to anchor the system down to its brackets. And I think that's good because you're not having extra penetrations into the roof that could cause leaks and that sort of thing. If you're talking about a concrete roof, then that, potentially penetrating the concrete membrane with anchoring bolts to hold that down can be an issue if it's not sealed, back sealed properly afterwards. But a lot of installers are moving completely away from that sort of thing anyway, and just putting ballasted systems up there, self-ballasted systems. So it's essentially using concrete weights to weigh the system down. It's all designed and engineered so that it can handle the wind loads in that area and not blow away. And that way you're not penetrating any roof membranes and causing any potential issues, for leaks and that sort of thing later.
Okay.
Jack might have some more to add.
I I mean, I'm not a solar installer. We're not a solar installer, but I think it really comes down to having a reputable installer, and we vet all our partners to a very high level. So to help ensure that each of the installs are done to a really professional standard, and also looking at the sort of the terms and conditions of how a system's installed. And again, using sort of ballast options, like Ethan said as well. So yeah, I think just using reputable companies is probably the number one source of making sure that isn't an issue.
Most installers have a like a 5-year minimum 5-year workmanship guarantee. So if there's ever any issues, they're going to come up within 5 years, I would think, and you would they'd come up in less time than that, I think.
Okay, we've got another question for Jack from Damien from Renew. If 10 out of 50 residents do it, install SolShare, and then another 5 become interested 12 months later after install, can they join in? Does this reduce the benefits of the first 10 who set it up?
Yeah, this is quite a common question, to be honest. And the answer is, the answer is pretty tricky. It depends on a few things. It depends on whether the 5 connections that are left are suitable for the 5 connections that wanted to join in. I won't get into the details of it, but it's all about what phase those apartments are on. So it's a bit of a tricky answer to maybe, but I think the main challenge with it is if everybody's paid into a system. So if they've all paid in $2,000 for the system, and then a couple of years later 5 more people want to join in, how do you manage them sort of buying into the system? So there's a little bit of sort of challenge around that. So of course it's best to get everybody to sign up and join in as and when. And it's also not an impossibility, but certain things have to be work correctly for us to be able to join more connections. What we can do is, if there's 5 people who are sort of maybe not 100% sure, or maybe they need to wait 12 or 18 months to club together some money, we can connect those people, and but we can not connect them to the solar. So if they want to sort of think about it for 12 months, we can connect them up at no additional cost. And then at 12 months time, they go, actually, you know what, I'll be really interested. I'm actually really keen on this, when they see all the glorious benefits that the neighbors are having. And then it's a simple case of us connecting them via an online portal that we have. So yeah, there can be some challenges around it, but it is sometimes possible.
Okay, great. Another question for Ethan. Can you suggest a Melbourne-based colleague who offers this sort of service that you provide? That's from Kerry in the Whittlesea Community House.
Not off the top of my head, but I'm happy to take that one on notice and see if I can have a think about that.
Okay, great. Another one for Ethan. With NABERS ratings being closely tied to the energy mix of the grid, we will see improved ratings as the grid becomes decarbonised. What are your thoughts on the use of NABERS in the future because of this? And your thoughts on the inclusion of a star rating based on the energy efficiency of the building, e.g. megajoules per occupant?
That's a nice technical one. Yeah, look, definitely as the grid decarbonises, then yes, the tons of CO2 per kilowatt hour consumed will decrease. The NABERS tool, I don't think it's going to have a drastic impact in the really short term, but certainly the tool does get reviewed on a regular basis, and adjustments are made for as the, I guess, the building pack moves towards more efficiency as well, they try to set up the you know, the calculation tool such that you know, the 3-star is the median over time, and I think there'd be some adjustment in that for that. But I think that the technical nature of that might be one for the actual for the NABERS administrator. And the second part of the question was the value of the star rating going forward. And I think that's kind of the same thing. I think that the tool's designed such that, you know, 3 stars should be pretty close to average as time moves on.
Okay. I guess it potentially could be an option to recalibrate, like what happened with the fridge energy ratings.
Yeah, exactly. And I think that's done on a reasonably regular basis.
Yep. Sorry, I'm jumping around here. Question for Jack from Peter. Does the sole share need any active management by a loom, which would lead to ongoing costs, or by the building owners?
No, it doesn't. So it all works internally. It's not a sort of, it's not AI, it's not predictive or anything like that. It actually works instantly. So whatever you're doing at that specific time is fed directly to the sole share, and then we change the switches all internally. But we also, it's also 4G enabled, so we're able to over the air update it if we're able to figure out some coding in 12 months time that's going to save you more money. And we're also able to offer a portal as well, so you can actually you'll be able to see how much money you're saving, how much solar is coming to your apartment, how much what your grid usage is, so you can start to sort of change your energy habits to try and save more money. And that's all that's all free of charge.
Okay, great. Now, we've been going for an hour and a half. There's still quite a lot of questions. Are you both happy to keep going?
Yeah,
happy to.
Go for a bit longer.
Okay, one for Jack. Can this system, this is from Chris, can this system be used for a group of strata titled villa units? If so, what is the minimum number? To make it viable, I guess.
Yeah, again, it's a bit of a case by case basis. So we actually we connect the solar to the main switches of each of the apartments. So it really depends on where the meters are, where the main switchboard is, where the sort of inbound energy is from the grid. It's quite useful to know as well. It also depends on how easy it is to get all of the solar from the various roofs to one location. So it can be a bit of a challenge if there's sort of gaps between the villas and things like that. But and we need to figure out where certain things are. But yeah, you know, if it ticks those boxes, then we can absolutely do it. The smallest number of apartments that we've connected to are 3, and the largest number of apartments that we've connected to is 52. So that gives you a bit of an idea of the possible range.
Okay, question for Ethan from Paul. When it comes down to slowing pumps and fans down, is it safe to do so within manufacturer's specifications and warranties?
Yeah, but that's something to always check before installing a VSD or a motor controller on a single phase pump. Most electric motors have a little fan in the back of them that's sort of on the back of the shaft, and that draws air across the windings to cool the motor. So that's one thing to consider, is if you slow that down, is that going to be have an impact? But I guess what we find in most cases is that the lower load on the motor helps them to run cool anyway. So the restricted airflow is not usually a concern, but it's pretty easy to find out whether or not your particular motor is suitable for slowing with with a VSD, it's just a matter of contacting the manufacturer and stating the model number and asking them if it's suitable. But most bigger three-phase motors are suitable for VSDs. The other thing that you've got to consider as well is that whatever the motor's attached to, the pump or the fan, it will have an efficient operating curve. And if you slow it down to a point that falls off that curve, then it's not going to be shifting any air or water. So you've just got to be a bit careful about how you tune them and what the minimum speed that you can run them at and they still be effective is.
Okay. This is for Jack from Andrew. We've got solar panels for our common area power already. Can the SolShare system be retrofitted to that? They have 91 apartments.
It can be, but my initial thought would be that you've probably not got enough solar supplying your common line power load to warrant adding in some additional apartments. So it may be the case, but may not. So we could either look at incorporating a SolShare system into that existing solar system, or you can just add more on. So the SolShare is modular. So if you can add sort of 1, 2, 3 systems to connect more or less apartments. So this can be in addition to your common line power system. But I think it's worth pointing out as well, all of these sorts of questions of can the villas be connected? Can this work on this? These are all great questions, and all you have to do is send an email. Go on our website and send us an email with a few details around your apartment building, and we'll get back in touch with you and talk to you about go through all these questions with you. And yeah, so essentially, if you're in a multi-tenant building and you're interested in solar, then we can have a look at it. So don't worry about the finer details.
Yeah, there are quite a few questions about the different types of roofs and so forth. So I think we'll probably scan over them. Okay. Is Ethan, one from Richard. It's a bit off topic, but what needs to change in building standards, codes, etc., to make sure that apartment buildings are designed, constructed, energy efficient from the start? Minimum required NABERS rating, perhaps.
Yeah, that's a tough philosophical one, and there's a lot of advocacy going on around that at the moment, particularly from the City of Sydney, ones that I know are working hard, I guess, behind the scenes to improve those minimum standards. I think NABERS is a good thing because it's exposing the disparity between pre-construction standards like basics and that sort of thing, and then actual building performance afterwards, and Green Star and that sort of thing. So it's sort of exposing those those disparities and holes, and hopefully that will sort of lead to better standards. But it's very my understanding is it's quite difficult to change the BCA and National Construction Code and all that sort of thing. It's not an easy thing to do. Graham, you'd probably know more about that than I do.
All I can say at this stage is watch this space. Yeah. There'll be updates in 2022. There is also, as you mentioned, the likelihood of mandatory disclosure being taken for existing buildings. That's being looked in at, and COAG, the energy ministers of COAG have committed to that coming in. They're hoping to have a workable model available by the middle of next year. So that means when you lease or rent or sell a house, a dwelling, you may have to have some declaration of what the energy efficiency is, and that will trigger the need for people to hopefully retrofit their buildings to make them more energy efficient. So there is the government is doing a lot of work on that at the moment, and it will start to feed and trickle into the building regulations and other policy areas over the next couple of years. Okay. One for Ethan. Are any of your case studies willing to share their own experiences, committee to committee sharing?
I think so. Yeah, there's certainly one who I've seen. There's a representative from one of the buildings. I think he's online right now. I saw his name pop up. So yeah, there's, you know, I think there are buildings out there who are willing to share their stories. I'd have to sort of check on a case by case basis, but yeah, again, if you want to send me some details on that one, I can try and make contact and put people in touch.
And Jack, do you have any comment on how the system works with units that are tenanted, not owner occupied?
Yeah, absolutely. So if we look at the two delivery models for the sole share, so the CapEx is often where this question gets asked when a landlord would be paying for the solar system and essentially sort of not receiving the benefit. But in those cases, some landlords just do it out of the kindness of their own heart, and some use it as an opportunity to say, well, I'll install this system and then we can do a 50-50 split on the energy saving. So if they're saving $10 a week, which is pretty standard for a sole share system, they could increase the rent by say $5 a week, and then they'll get their return on investment for in about 5 years. So that's one way, or the other way is the no upfront cost model, and of course, as it's no upfront cost, and the individual residents will be signing up to the discounted energy rate, then of course the landlord isn't having to pay any money for the system, and they're also not having the tenants are winning by having a reduced electricity bill. So it depends on which method they go to which benefit you can get.
Okay, there was mention earlier of embedded networks, so there is one question about embedded networks from Jeff. I presume sole share is incompatible, redundant on buildings with an existing embedded network. What considerations are pertinent when looking at transitioning away from an embedded network?
Yeah, so there's sort of a two-part question. The first one is there's no reason why a sole share system can't be installed on an embedded network. So essentially, it gets fed behind the meter to any meters. So that would just be your sort of child meter, to use the lingo. So yeah, not a problem there. The challenges with embedded networks are, you know, are quite well known, and there is sort of continual legislation that's coming out to assist apartment owners and residents from being able to sort of exit an embedded network if they want to. I'm not an expert and not really best placed to give you a sort of a solution, but I do know that there are more and more sort of things coming out to assist in the leaving of an embedded network if you know, if it's not suitable. But I think one of the best things you can do from an embedded network point of view probably is to actually approach them and say, look, I'm looking to leave. I've read the legislation that I'm able to, so you know, how can we sort that out if you're looking from a sort of particular rate that you're getting from an embedded network. But with regards to actually installing a sole share system, then yeah, it's still possible to do that.
Okay, still more questions for you. One from Lucas. What sort of lead time is involved for sole share? Are there any regulatory obstacles or issues with the network service provider you're aware of, especially in New South Wales?
So lead time's a bit challenging because it depends on things like when you can set up an EGM or an AGM. But once one of our providers can assess the building and generate a proposal for you, that can either be the sort of the CapEx or the no upfront cost proposal. You know, how long could that take? I don't know, a few weeks maybe. then the proposal has to sit with your with the owners corporation for a month before you vote on it. So that's a couple of months, and then an install can happen as quickly as another month. So maybe 3 months or something. Maybe a bit less if you're really lucky, but yeah, I would have thought probably a minimum of 3 months. Could happen a bit quicker, especially if you go for the non-CAPEX solution. And yeah, you're quite right to highlight the DNSPs. So this is a new technology, and we have had to work with all the DNSPs to get them to understand what the soul share is, to make sure that it's safe, it's safe for the grid, it's safe for the residents. That's obviously our number one priority. And so that process has all been done for the majority of the DNSPs around the country. As I mentioned earlier, not in Western Australia or Northern Territory yet. But yes, the other ones they're familiar with our technology and being able to install it on the grid. So that's something that yeah, we've had to work on.
Another question for you, Jack, from Sonia. Who are the retailers that offer the sole share on-bill finance? Would the common area account need to transfer across to the new retailer as well as tenants?
Yeah, so in New South Wales, we're working with the company called LPE. They and yes, one of the aspects is that the common line power is part of the connection. But again, don't see why you wouldn't want that, because essentially you'll be able to save more money by having a connection with them. And then all the apartments can opt in separately to that. And then we're about to do our first pilot with Origin Energy in Victoria as well.
Okay, great. One for Ethan from Kerry. Have you found the limiting clauses in basics are problematic for developers? For people in other states, basics is a regulatory requirement in New South Wales for confirming that you achieve energy and water efficiency requirements. So are the limiting clauses in basics problematic for developers and or councils, both creating energy emissions efficiency incentives earlier in the design process, rather than having the audit and likely retrofit later when residents suddenly find they have a pretty inefficient and costly building? My comment on that is that basics and the building code are the minimum requirements you need to achieve. It's not necessarily the best outcome. There's nothing stopping developers and people exceeding those requirements. But as I mentioned earlier, they are going to be increased for the update of the National Construction Code in 2022. It hasn't been confirmed whether basics will increase their stringency in line with that, but it's most likely to happen. I don't know if you want to add anything, Ethan?
Yeah, look, I think you've covered it pretty well, and you know, I guess the addition of the NABERS apartment tool has it's shining a light on these things. NABERS has only been around for apartments for 2 years now, just recently 2 years. So these things are popping up, and it is on the radar now for local and state governments, and hopefully the federal government as well, so that hopefully we can sort of bridge the gap between the the pre and post construction ratings.
Yeah. Another question for you, Ethan. What is the usual cost to employ an energy efficient consultant like yourself for an apartment building? And are there any government grants to cover an energy assessor's costs?
Look, it varies, depending on the complexity and the size of the building. So it's hard to say. I'd have to, look at the building before I'd know how much it costs. But it all depends on how far you want to go, I suppose, as well. And yes, look, there are lots of incentives around, and I provided some links to Doug, and I think he'll put those up shortly, of the ones that I'm aware of in my sort of in the sort of Sydney centric sphere. Certainly, there's several councils around the Sydney area who are offering subsidies for energy audits and that sort of thing with this type of thing. And then there's also other state government programs. Again, in New South Wales, there's one where you can get some energy coaching as well, and that's being adapted for residential strata as well as we speak. So early in the new financial year, we should see an adaptation of that New South Wales Energy Saver energy coaching program that gives a certain number of hours of sort of free coaching to a building to help with this sort of thing. But yeah, I would say probably have a chat to the sustainability department of your local council in the first instance, and I think that'd probably be best place to point you in the right direction of the incentive programs in your area.
Okay, I think might call a halt on the questions at that point. There is still quite a lot more, but we have been going for nearly 2 hours. So I'd like to thank both of our speakers, Ethan and Jack. I think you all found it really informative. With that, I'd like to thank everyone for tuning in, and we'd say good night.